Let me show you something interesting today. I have built a model for concrete strength prediction. So I have attributes like cement, slag, ash, water, superplastic, etc. Based on these attributes, I am predicting strength of the concrete. So if you could recollect what is linear regression is building mathematical relationship between independent variables and dependent variable. So here dependent variable is strength of the concrete, independent variables are here, right? So I have built the model. I will show you how to build also. But let me show you with some random values. I am just trying, right? 24, something randomly. So what you can see here. So let me give some water also. And for age, let me give something like a 13. And let me give submit now. So you can see that it is showing the strength of the concrete, right? So basically, this is what we are trying to get through machine learning models, right? So let me show you how I have built this model. So for understand this concept, you should know what is linear regression. Also, I have shown a very basic hands-on for simple linear regression. Also, you should know about R square, adjusted R square. Then if you look into this video, you can definitely understand it better. So for this, I have imported NumPy, Pandas, Matplotlib and Seaborn. Sometimes I may be getting some warnings. So I have imported that. Machine learning is always splitting the data into train and test. So I have done that. I'm just going to implement only linear regression for now. And this matrix is to calculate R square. So I have loaded my data set. Let me show you how my data set is looking like. So let me repeat the problem statement. Predict the strength of the concrete based upon cement, slag, ash, water, superplastic, coresag, finag, and age. So now the top 5 observations are being displayed. You can see some zeros here, right? Here, you can see some zeros. So this zero can be missing value in some data sets. But here I checked with the construction team already. They told me like a superplastic can be zero for certain data point, or ash can be zero, slag can be zero. So that is perfectly fine. So it is not actually a missing value. This can be zero also, right? So let me show you whether there are missing values in the data set. You can see that there are no missing values over here. I am not actually more focusing towards data visualization now. Maybe I will pull out some more projects and I will show it in the upcoming videos, because here the scope is just to make you to understand how to build a model, right? So that's what my goal is. So there are 1030 rows and 9 columns in this data set. Let me see the correlation, right? So this will give you an amazing inference about the machine learning model. What is the dependent variable here? Exactly. So strength is the dependent variable. So let me see here. The correlation between strength and cement is 0.49. So what I can conclude, it is moderate correlation, because the value is between, the correlation value should always between 0 to 1. If it is close to 0.5, then it is moderate correlation. You can see negative, but not really higher magnitude, right? So this itself, right, indicates that linear regression may not be the wise chance, because the correlation between dependent variable, that is strength, and independent variables should be high. High in the sense it should be close to 1, but we cannot see anywhere close to 1. So definitely this is not really a great data for building linear regression model. Still, let me go ahead with that. Let me also go ahead with the pair plot to understand how the correlation is. So you can see here cement and strength only, you can see positive correlation, but the points are not really crowded. If the points are really crowded, then the correlation value would be close to 1. But you can see here it is little farther apart only, right? So this will also give an indication about it. So now I'm not getting into any of the data preparation step because no missing values. Maybe outliers I can deal with that, but for now my goal is not that, okay? So in the y-axis, I need to take the dependent variable, which is strength. In the x-axis, other than the dependent variable, I have put down all the independent variables. I'm splitting my data into train as well as test. So for that already I have imported train test split. Test data is 0.30, which means that train size is 0.70. Let me instantiate the linear regression model and then I'm fitting it with the train data. So let me also try to get the score of train data as well as score of test data. So what is meant by this score? This score is nothing but R square. So I hope all of you remember that, right? We have already discussed about it. Score is nothing but R square. So if you have missed out that video, I will be giving this video link in the description. Please click on that, go through the concepts and come back. Okay. So R square, which is nothing but accuracy. So I could see that this can give only 60% score. And for the test data, it is giving 63%. According to me, it's not really a great model because if the score is close to 1, then we can say that the model is an amazing model. So maybe in this scenario, what we will do, we will try to just go ahead with other machine learning models. Okay, for now, just because the goal is only to go ahead with a linear regression, I'm stopping it over here. Then also I want to show you the equation. You can see that these are the coefficients. So what does this indicate basically? These are the coefficients. You can see, right? What are we finding out? Strength. So strength is equal to 0.1265 times cement plus 0.108 times slag and so on. Plus C, intercept is going to be minus 52.96. Okay, so let me also show you how I got, in case if I want to deploy it, right, with the Gradio, how I can do that. So for that, pip install Gradio, always you install it. If you are writing in Jupyter Notebook, not necessary to install it all the time. So I have done the installation and kept it ready. I have imported Gradio and just I'm showing it, right? So the input attributes, independent variables, I have passed it over here. And then I'm creating a data frame and I'm predicting with the model that I have built there, right? So what are the inputs? I'm giving it over here. So what is the output? I'm going to predict the strength over here, right? So now you can see here, when you give some input values, it would be giving the strength of the column also, right? Say for example, you want to check randomly with some data, right? For example, let me pull out the first data and I will show you so that I think you can understand it better. Cement is 141.3. So let me change it like that, 141.3. Then slag is 212, ash is 0. Two zero 3.5. So core sag is 0. Sorry, super plastic is 0. Water is 203.5. Ash is 0. And then super plastic also 0. Right? And then core sag 971.8. Fine ag is 748.5. Age is 28. Okay. So in case if my model is predicting without any mistake, it should actually give 29.89. but that cannot be the scenario because my model is giving just a 60% score only, right? So definitely it is not possible, but still let me check. Okay, so what I need to do, I need to click on the submit. So you can see that it is giving me the result like a 20.53. But what is the expected result? 29.89. So one more thing you need to understand, because I think this is really important. Most of the times what people think, okay, this is 29.89, but my model is predicting like a 20. So whether this is wrong or not. Now what you need to understand is about R square basically tells us how close the predicted value is to the actual value. How much closeness is there between predicted value and the actual value, right? The actual strength is 29.89. The predicted value is 20. Not really a good sign, because already we have seen that the score is 60% only, right? But when we build a very good model like 90%, we can see that the predicted value would be closer to actual value. So how much closeness can be there? Everything depends upon the problem statement. I cannot say anything about it. Maybe according to this data set, if you ask me, I need to check with the construction team, maybe the product manager, that whether this value is fine or not. In case if my manager is not really happy about it, there is no other option. I'm supposed to go ahead with the other models only, right? Very simple. Just I have built a very basic model. Okay, we will also really work with a very nice data set in the upcoming videos. One more thing what I want to say is please subscribe, because I could see that 90% of the viewers are non-subscribers. Okay, so if you just subscribe it, I can take it like a token of love. It may really motivate me to do more videos, right? So please subscribe, like, and if possible, you can comment also, and please share it with your friends. Thank you so much.